Hello and welcome to this Commodore 64 programming tutorial. In this video I'm going to be recreating the classic arcade video game Pong, written entirely in Commodore 64 BASIC. And if it's not already clear from your own experience or my other videos as to why you don't write a video game in BASIC, that'll become painfully clear shortly. But nevertheless, it was good fun to make, and hopefully you'll learn something from it by going through the when I go through the code with you. So without further ado, let's load the game. And I'm using the Vice emulator here just because, just for convenience, so I can make this video, but also because it has a warp mode, which will come in handy. So because of the pace of the game, the blistering pace, I didn't just want it to start and throw you straight into the game and have the ball flying around everywhere. So we just have this screen on a loop here, waiting for a key press before the game will start. So let's go. And here we are. So the player 1 bat is on the left, player 2 on the right, and I don't know if it's possible to read more than one key press at once with a Commodore 64. So it had to be one player Pong, hence calling it one Pong. So when player 1's bat goes up, player 2's goes down, and they're just controlled by pressing the W and S key. And as well as being able to create this video easily using an emulator, you can engage warp mode, which I'll show you in a moment, but that does have the effect of disabling the sound. And there are sound effects with this game. Get ready. Hopefully you heard that. Just a little kind of, I wanted to create kind of a bash sound, if you like, you know. Yeah. Kind of a bit of soft white noise. So what I'll do is I'll engage warp mode now, which does speed the ball up somewhat. And the movement of the bats up and down. And I'll just disengage it when we get close to the other player's bat, so you can hear that sound effect again in all its glory. Here we go. Alright, you might also notice a momentary pause there on the ball as that bit of BASIC that handles the sound effect is played. But anyway, with warp mode engaged, it's still just far too slow to make it fun. But you know, there's quite a few things. We've got sprites going on here. We've got text mode graphics, yeah, to create this screen. Sprite collisions going on, and this is about the size of it. I'll show you what happens when somebody wins. Now, obviously, there's a lot more that could be done with this game. Scores, keep track of the score, that sort of thing. It really is, at the moment, one and done. So you'll see if the ball reaches the other side, and as the ball went off player 2 side, player 1 wins. Press Y to play again. Any other key to quit, so press Y just to show you that. It takes us right back to the starts. And there we go. Now you notice the ball didn't start moving in the same direction as it did previously. When it started off before, it was moving up and to the left. This time it was down and right. Now let's see player 2 win this time, shall we? There we go. Player 2 wins. Press Y to play again. Any other key to quit, so let's quit. Thanks for playing. Goodbye. So let's go over to the source code and walk through it. So here we have the source code for Pong for 1. And I'll try and keep it as brief and concise as possible without going off on too many tangents and rambling on for too long like I'm doing now, but whilst also explaining things as clearly as possible. If there's anything you need more information on, by all means leave me a question in the comments and I will come back to them later. Okay, so line 0, here's something you might not know. 0 is the lowest valid line number for a basic program on the Commodore 64, so 0 is perfectly fine. If you do use 0, you could then use, if you wanted to for a single line program, go to with no line number after it, and the basic interpreter would then, if it encounters a go to with nothing after it, would automatically take you back to line 0. If there is no line 0 in your program and you use go to without a line number after it, you'll just get a syntax error or some other type of error. Okay, so the first line that actually does anything, line 5, go sub 1000, and that'll take us down here to where our sprite data is. Okay, so we've got 2 bats and a ball. Now, the bats are identical, but I couldn't find a way of using the same data in two sprite memory locations. So whenever I tried to just read the same data into two different areas, I got out of data errors. And now there might be a clever way of doing this. I didn't have the patience to work it out, or to look it up. So it was easy for me just to copy and paste these 4 lines of code, 4 lines of data, in again. And then the ball data is obviously different because it's a ball. So that's on its own. But the whole program, whole listing, even having done that, is still under 100 lines of code. So you can create something, kind of cool, kind of playable. Certainly, 8-year-old me, if I'd created this, would have been absolutely wowed.
Wow!
Would have been proudly showing it off to all my friends. After we return, we'll come to a for loop which reads in that data into the relevant memory location. So starting at 12,800 up to 12,192, we're going to read in that data. So it's in the correct locations, ready to be used as sprites. Previously, I've used separate for loops for each individual sprite. You can just do it all in one. So starting at 12,800, the first 64 bytes of data would get read into 12,800 to 12,863, and then the next 64 from 12,864 to 12,927, and then from 12,992. I think I've got that right. Anyway, so it's 3 64-byte chunks. And once that's done, we clear the screen of all text, and then we can set up a couple of variables for the X and Y coordinates here. Then we're going to do some poking. So the first thing we do is set the border and the background color to black and the text to white. I like that because it makes the screen look bigger and gives us the maximum contrast for any text we're going to display later, and there will be some. And then the sprite pointer for sprite 0, so the first sprite, is going to be set to 12,800, and then we poke in the X and Y coordinate into the memory location for sprite 0. Then we're going to double the height of each bat, so we're going to set bits 1 and 2, the byte for the Y, the sprite double Y to on, otherwise the bats would be rather small. And then we are going to, for sprite 2, we're going to activate the most significant bit so that we can display it in the right third of the screen, so in an X position greater than value 255. So as I've explained previously, the width of the Commodore 64 screen is 320 pixels, and 255 is the maximum number you can put in an 8-bit byte. If you try and put any more than that, then you'll just get an error, the program will crash. So you have to set this particular bit for the particular sprite you want to display in the right third to on. Then we can reset the X coordinate to 0 and use that from 0 to 45 to then use. And then we just set the sprite pointers for sprite 1 and sprite 2 and the X and Y coordinates for those sprites. And here, rather than change the value in Y, or put a hard value of 155 in here, I've done Y plus 10. So really just to show that it can be done. So rather than change this value, it'd be 145 plus 10, give us 155. And then here we've got our message, press any key to start, and I've just used the print. So a question mark gets changed into print by the Commodore 64 into the print command. Tab 8 means move the cursor over 8 spaces before printing the string. Now on the Commodore 64, everything is in uppercase by default. So when you paste something in, it should be in lowercase, which is what the C64, certainly the emulator, will be expecting, and it will display it all in uppercase. I'll explain why. I've said that in a sec. First, there's the kind of start loop, if you like, the first loop, which sets up the A string with nothing in it, asks for an input. If there is no input, then we just go to the start of the string and do it all over again. As soon as there is any input, press any key to start. So as soon as any key is pressed, this if statement is false, so the goto is not executed, and we go through here, which again clears the screen, so it gets rid of this message that we've just printed. And we have all these print statements here. Now, these were not done by hand. That would have been a very long, laborious process, which you had no choice but to do back in the 80s. At least I don't think there were. There probably were screen editors, but I just weren't aware of any. So I used a program, a development environment called CBM PRG Studio, which I'll link in the description as well. But that's fantastic. It's only available on Windows as far as I know, although you probably can emulate it if you wanted, on another system. But anyway, a Windows program, and that has built-in things that let you create music, sprite editor, and screen editor. It's equally as good at for creating basic programs and assembly programs. It's just an excellent development environment specifically for creating programs for the Commodore 64. So it allowed me, in a kind of paint package style, create the screen. So I just drew in all these characters, and then you copy and paste the code it produces into your main source, and there you go, you get the screen. So what we have here is the message at the top, as you saw from the demo before that was showing. One Pong. The last line of the logo, if you like, or the graphic at the top, looks a bit skew-if because I've used here in curly braces blue to change the text colour so that player 1, P1, is displayed in blue, then back to white to finish off the bottom of the logo, and then to red for P2, and then back to white for the rest. Now, the significance, the reason I mentioned that and yeah, this isn't just null space, these are spaces in here. So you can kind of get an idea from the listing what it's going to look like. You just might not be aware of what these characters are going to look like until you run the program. Now, by displaying an uppercase U, printing an uppercase U or an uppercase D, what you get on the Commodore 64 or on the emulator is the character that you would have got if you'd pressed Shift and D on the Commodore 64. So in this case, it's a horizontal line, and the U is a kind of a corner graphic, if you like, for the upper left corner. I, the same, the inverse of that, so for the upper right corner. 1, 2, 5 are vertical lines to denote the left and right edges of the playfield, if you like. And obviously, well, presumably, I should say, that the character that this 1, 2, 5 gets converted into isn't available by doing a shift and a key press. Otherwise, we'd see uppercase letters down the sides here. And at the bottom, we've got the corner pieces, J and K, and F are, again, horizontal lines. You might think, well, why aren't they Ds? Well, they're slightly different in that the horizontal line in that character tile is that horizontal line is slightly above center with the D, slightly below center with the Fs. And that just gave the impression, it gave the effect of the playfield looking like an old CRT, a bit more like an old CRT TV. And Pong being one of the oldest video games, anything to give it a little bit more of a retro feel. And then afterwards I thought, because I could have just used another character, for the line to be dead in the center of the tile. And I thought, maybe I'll use... I'll check the character that's underneath the ball sprite to see if we've collided with the top or the bottom of the screen. That'd be a good idea. I didn't end up doing that. It wasn't necessary as it turned out, and it probably would have slowed things down even more. But that is a way of doing collision detection in text mode by seeing what character is being displayed in a certain cell of the screen. So anyway, we've displayed our screen. Down here, some more poke commands, and these are just setting sprites 0, 1, and 2 to white, because everything is black and white this game. And this poke here turns all sprites on. We're only using 3. I could have just turned on bits 1, 2, and 4. So if this was a 7, it would have the same effect. At the time, I just thought, look, I'm only, it doesn't matter. There's not more sprites that I'm going to be using. They're all going to be displayed all the time, so I just turned them all on. Okay, I set up a couple of variables here, XD and YD, and that stands for the X direction and the Y direction. So are we moving left or right or up or down? And that will be denoted by adding either a positive 1 or a negative 1 to the value already in the memory location for the X coordinate of the sprite. So I use the R&D function, the random number function. We want a positive number from 0 to 1. So as the numbers aren't inclusive, this number here denotes the upper bound. So that'd be 2, but it's not inclusive. So you'd get the digit below this, so 1. So 0 and 1. I've prepended the R&D command with int. Now R&D by default produces floating point numbers, which you can use. And if you're referencing that, testing it with an if statement, if it's above or below, and you're testing it against an integer, it'll still work. It will just ignore everything after the floating point. But you can put int before it so that it rounds it to an integer. Okay, so this will produce either a 0 or a 1. And the same here, it's identical command, 0 or 1 integer, so not a floating point number. Okay, then what we have to do is, because we'll be adding that result to the result already in that memory location. If it's a 0, well, nothing would happen and the sprite wouldn't move, the ball wouldn't move. So if it's a 0, we then just change it to a negative 1. And then what we're going to do after that is enter the main loop. So 400 to 500 is really the main loop of the program. We branch away from that with go-tos and go-subs, depending on certain conditions. So 53278 is the collision register, the sprite-to-sprite collision register. Now, When you first run the program, this will automatically be set to 0 anyway, but because BASIC is slow, I found that I was getting some weird effects when trying to bounce the ball off of the bat when it hit it. So to counter that, at the start of the loop, I just doubly ensured, although the ball should bounce away from it and then that register gets set, its memory location gets set back to 0, it wasn't always happening fast enough for the results to be reliable. So when we restart this loop, I just ensure that the collision detection is off. Sprite to sprite collision detection is off. Then I can set up the K variable. We've seen this before, and storing that the value in memory location 203, which is one of the locations for storing key presses. And then we're going to test against that. So if K equals 9, which I believe is the W key, and 13 being the S key, so W moves the bat up and S moves the bat down for player 1, and that has the inverse effect for player 2. So it's one player Pong, so move the player 1 bat up, player 2 bat goes down. Now if the game ran at any sort of speed, approaching playable, then it might be a bit more as you can see, even with the emulator's warp mode on, it's not particularly quick. And anyway, if W is being pressed and the Y location for the Y coordinate for sprite 0, the first sprite, is above 100, then we can move the sprite down by 5 pixels. And why not 1? Well, that'll just make the game even slower by moving it 1 pixel at a time. If this was written in assembly, then sure, 1 would even be lightning fast. But it's not, so we use 5. Now, why are we testing against, if the key's being pressed, why do we also want to make sure that this condition is true, that we're above 100 before executing the rest of it? Well, otherwise, the bats could just go straight through the edges of the box, if you like, the playfield that's been drawn around it up here. So in my testing, I found that 100 was the bottom edge, and 190 was the top edge. Okay, so just made it stop where it needed to stop. You can see here, if 9 is pressed, we move the Y coordinate for sprite 1 and for sprite 2. So whereas 1 would go up by subtracting 5, the other one would go down by adding 5. And the same is true for the inverse, so for going in the other direction. I want to make sure that we don't break out the bounds here. Okay, so we test for the key press, and then after we've done that testing, we then have a look, and this is for the ball sprite. We then look at the X location, X coordinate. If that has reached 255, and the most significant bit, so the only sprite that should be in the right third of the screen is the bat, then we branch out and go to 700. If the ball sprite is moving right, then we're going to switch on its significant bit. So with the bat still being displayed in the right third, we also enable the ball to be displayed in the right third, and then we reset its X position to 0. That's what you have to do, and you continue incrementing that all the way up to the next maximum, which will either be the right-hand edge of the playfield or the bat, if it encounters the bat. And then we return. So we have a look here, and this is kind of the opposite. So we check to see if the value of it is 0, of the ball sprite, the X coordinate value is 0. If it is, and the most significant bit is set on, then we go to 800. And 800X, are we moving left? If yes, then we're going to turn off the most significant bit for the ball sprite, just leaving the bat sprite in that area of the screen, and then reset its X, poke the value 255 into the X coordinate for that sprite. And then we can decrement from there to continue moving left across the screen. And we get returned. And so after all this checking is done, we then update the position of the ball sprite, and we add the value basically in XD to the X location of the sprite, and the value in YD to the Y location. Okay, now these might be positive or negative. We do that, we add that value into the X and Y of the ball, and we do some more checking. Now this number here checks for sprite to background collisions. If it's anything other than 0, then we've hit something in the background. In this case, because of the starting position of the ball, it will be the top, bottom, or left and right of the playfield. So if we've hit something, and the Y coordinate of the ball is less than 100, then we are going to invert whatever is in YD. So if we've bounced off the top, so less than 100 means we're in that top section of the screen, of the playfield, and this was just trial and error. I'd be, in a previous iteration of the code, I'd be constantly printing out the Y location, to find a good area to set this to, a good value to set this to. So if it's less than 100 and we've collided, then we invert it, and then this poke statement is just to make sure it bounces, because there's a bit of a delay sometimes, and that's why I've got this poke resetting the sprite to sprite collision anyway to 0. Didn't need to do that for the sprite to background, but I did need to give it a bounce. So I give it a 2 pixel bounce down. So adding 2 to the Y location would have the effect of moving it down. And so we do that, and then we carry on. If the X position is less than 30, and we're in the left 2/3 of the screen, by checking the most significant bit is only enabled for the bat sprite on the right hand side, then we go to 900. What's 900? I'll get to that in a moment. So that's kind of the end of the game, if you like. That means the ball has hit the area it's collided with something. It's gone past the bat and hit the left-hand edge of the playfield. And this 480, basically the inverse of 470. If there's been a collision and we are down at the bottom section of the playfield, then we invert YD again and we bounce it up by subtracting 2 from the Y position. And then this here, if the ball is in the right third of the screen, because this significant bit is set for the ball and the bat, and it's above 70, then we've hit the right-hand edge and we go to 950. Okay, if none of those are true, and this if statement comes back as true, meaning that there's a bit of sprite-to-sprite collision, we go to 600. So I'm going to do that one first. So we go to 600. We immediately invert what's in XD. So if we're travelling left, we'd now be travelling right, the ball that is. If the ball's travelling right, now we're travelling left. So if we're travelling left, bounce the ball by 2, again, just to avoid that problem with the sprite collision. Now I found that even this didn't work. Bouncing any more than 2 just made the ball made it jump too much and looked a bit jerky and a bit amateur. So I left it at 2. That's why I also then, when we go back into the main loop, ensured that it was cleared before carrying on and testing for the condition again. So if travelling left, bounce it to the right by 2. If travelling right, bounce it to the left by 2. And then, so we've collided with the bat, and I thought I'd put a sound effect in. It's only a short sound effect, and it's kind of almost like a bit of white noise that kind of fades out very quickly. It could have been a beep or a bloop, something like that, which would have been a bit more appropriate for the time, I guess, but I want it to be kind of like a bat sound. I don't know. In playing around, I didn't spend a lot of time on the sound effect. So what we do is we're clearing the SID chip here, make sure there's no data in it, and that starts at 54272 up to 54296. We're just poking zeros into it to make sure it's clear. And then I'll create a new variable S. I could have used L again, but anyway, I've used S for SID. Right, that starts at 54272 memory location. Okay, and then decrementing from 15 to 0 in steps of 1 and -1. And we're going to poke these values into the SID plus 24, that'll be 15, and SID plus 4, we're going to poke in at 129. And I'm not going to go into great detail here, but these set up like the kind of the volume. The volume is this one. The volume, the pitch, and the decay, and that sort of thing. So there's a little loop, so the sound decays away. Okay, so if player 2 wins, because the ball has hit the left side of the screen, then we'll go to 900. And if player 1 has won, because the most significant bit for both the bat and the ball is set, and we hit a location greater than 70 in that x-axis, x position, and then we branch out to 950. Now, they're identical really, 900 to 950, so 900 to 945 is the same as 950 to 995. So I'm just going to go through one of them here. The only difference being it would just say player 1 wins if we were in this block, player 2 wins if we're in this block. So anyway, 950. What this for loop does here is clear out the keyboard buffer. Now, as we would have been pressing W and S multiple times, the keyboard buffer can actually hold 10 characters, and they will be stored. The last 10 will be stored in there when we would have got to this location. So we're asking for a key press. Well, all those key presses would have been ready in and would have just instantly gone through this in a flash. So what we would do is we clear out the keyboard buffer. We then turn off all the sprites, clear the screen, and display the message player 1 wins. We leave a blank line, and then we print the message press Y to play again, or any other key to quit. And here we set up a data string with nothing in it. We ask for a key press. If there's nothing in it, we just repeat the line over and over. If that key press happens to be a Y, then we go to 10. Boom! We start all the way up here again. Actually, I should change that to 70, because we don't need to press any key to start. We've already said we want to play again, so change these to 70. If not, if something else is pressed, then we get thanks for playing, goodbye, and the program ends. Just like this video now has. If you've enjoyed this video, please like and subscribe so you don't miss future content. Any questions or comments, please leave them below.